Hey everyone, I'm not a game developer, but I think we can all agree that building games is fun. Especially it's fun to do so in the language you like. So can you actually build games with Go? And yes, you absolutely can, with some limitations obviously, but nevertheless. And I'm not talking about web-based games or Electron games, we're talking about native stuff here. And let me show you some libraries you can use to build 2D or some simple 3D games in Go. For example, there is Ebit Engine, formerly known as Ebitan. It's a simple library to build 2D games in Go. And I actually built one snake game in Go using that and actually enjoyed the whole experience. You can compile this game into WebAssembly, into Wasm, and yeah, it just makes it easy. There is no CGO as far as I know, so great library to use for simple 2D games. Then we have a very popular C library called Raylib for video games programming, and it has Go bindings. It's a really great option. Unfortunately, Go bindings use CGO, so it's probably very hard to compile it into Wasm, or maybe even impossible. And then on the other hand, we have few more packages, maybe less popular, to work with video games programming in Go. For example, there is a G3N for 3D game engine. You can also write extensions for Godot using Go, so you can write, for example, shaders in Go. And I believe there are many more packages similar to this. As you can probably see, the list is not huge, and to me the clear winner here would be the Raylib. And I think so because Raylib been here for years. It has really fun and simple API, kind of split into these modules, really easy to use from any language. And if you learn this Raylib API, you can then switch from Go to Zig, for example, where maybe it's a nice option because Zig has a C compiler in it, so you don't need to use something like CGO. But yeah, the API is really well known. You can achieve a lot, so there are collision mechanism, textures, shapes, audio, text, and as you can see, there are probably hundreds of functions that you can use in your game dev process. And with that being said, let's dive in and develop a small but famous Minesweeper game in Go using Raylib. And now back to Raylib. And before jumping to Go bindings, let me first quickly summarize what Raylib is and what it isn't. First of all, Raylib is a library. It has a flat set of APIs, but it's not an engine, right? So it doesn't manage the game state or game mechanics. It's a C library as we already know it. It has no dependency as far as I'm aware. It supports 3D and it's cross-platform. And here on the Raylib website, we can see its architecture of the version 5.5 that describes all the modules it has. And now let's open the repository with Raylib Go bindings. So it's gen2brain/raylib-go. Now let's make sure we have everything installed. So on Linux, you'll need to install libgl, libx, and a few other packages. On Mac, you'll need command line tools for Xcode, which is probably installed already. And then here's how you can compile it for Windows. So once everything is set, you can then go get the Raylib package. And if you look at this repository, yes, there is a package called Raylib, but there is also a package called RayGUI. And RayGUI contains various controls from the ImGUI, so immediate mode GUI. And if you open this image, that's what it has, kind of different buttons, select boxes, so quite handy, and we'll be using these in our game as well. All right, let's initialize the project and then go get Raylib as well as RayGUI. Awesome, so we should have everything to get started. Okay, so we are building the Minesweeper game. And actually remember in the late 90s probably or early 2000s, I didn't have yet PC at home, so I would visit my mom's office and play video games there. And it was on Pentium PC and maybe didn't have much games, but Minesweeper was already there because it came with Windows pre-installed. And for those of you who don't know, Minesweeper is this puzzle field game where the mines are planted randomly and you have to guess where they are by reading these hints, like numbers of adjacent mines. And so the rules are well understood and the UI is simple as well, which I like as backend engineer, let's say. So let's start writing some code. And I will be speeding up on some boring parts and focus only on what I find interesting. You can still find the full source code in the description. I'll put a link there. And I would say we start with this example right here. Right, so it's main loop. So as you can see, we imported the Raylib library and we use its API. So we initialize the window with the size and the title. We define the closing of this window. We set the target FPS, frames per second, and then there is a main loop to draw. Right, so here we just simply check if the window should close, otherwise the program will exit. And between the begin drawing and end drawing, all our kind of appending to the screen should happen. So drawing the text, drawing different buttons and game elements. Okay, so let's tweak a few things here. So we'll call it Minesweeper, and we'll define also the size of our screen. So you can do... So let's just run it as is and make sure that it works. Make this smaller, and then we can simply do go run dot. And by the way, the first run is usually slow because Raylib needs to compile a few libraries. Also, the text didn't fit because I reduced the size, but that's fine because we'll be changing this anyway. So let's close that. So obviously a game like Raylib needs to have a state. So we can define the state struct, right, with different parameters inside. So what do we have? Imagine our game has few view states. One would be the menu, where you kind of select some difficulty options and then proceed to the game, then the game itself, and then we can have state like you won the game, so we show maybe the congrats, you lost the game, we show the bombs. We also need to store the field itself as a matrix, the amount of rows and columns, and maybe some information like how long did it take you for this game to complete, so some counter. Now, our field consists of different tiles, or we call them points, and they also could be in different states, right? They could be revealed, they could contain the bomb, and they also should hold the information how many bombs are around. So let's define this struct as well. So we'll start with maybe hasMine as the main one. Then we'll have the maybe open if it's revealed, right? Marked, because user can mark it. I believe that the mine is there, and the counter, there's internal mines around. And then our state can have few methods. So we'll be doing this on state. Maybe the first one would be to reset. That kind of sets the default configuration of our state. So we can do state maybe game 1 equals false, then also game over equals false, and then we open the menu, so our menu will be true. Now, because the game can be in multiple view states, I want to also define these small methods to render the specific view states. So we can do state, maybe the first would be to draw menu. For now, let it be empty, we'll come back to that. And then as well state draw field, right? And the last one would be draw congrats, right? So when you finish the game and you won, you'll kind of give a nice message, maybe show some button here. So that's basically our 3 view states. If we lost, if the game is over, we will do it directly in the draw field. So we will kind of reveal the field and show the bombs. Now, in the reset function, I don't reset the amount of rows and columns, so they will be set from the menu. There will be some buttons to choose the difficulty, let's say. Cool, so now let's go to the main and define our game. Right, so that would be pointer to state. Now let's set some default rows. I believe the beginner is 9 and calls is 9, and then amount of mines will be probably 10. And then we can do game.reset just in case. Now, a very important part, the size of our screen depends on the amount of rows and columns. So we need to kind of center the screen every time maybe some settings change. And we can do it in this main loop, but before the drawing, right? And we can have a function like center window that receives the width and height, and then sets the size as well, centers it, right? So it takes the monitor width and height, and then calculates the offset position. And so we can use it here, right? So if we want the default size, we'll use center window, and then we'll pass the default values as we have. Otherwise, we also call it, but maybe we'll do on the game. I'll define them in a moment. Now, to determine this size, I also need some constant that will be probably the size of our tiles. And let's do 30, for example, and yeah, come back to our state. Here we can have so the width would be you'll get this size multiplied by state dot columns, right? And it's int 32, so we can do something like that. And then the height would be also similar size, though here we'll have rows. And I actually also want to have some small status bar on the bottom, so I'll add additional size here as well. And now go back to our menu. We still need to draw, so we can remove this default text. Maybe we can change this to, let's use dark gray by default. And then after clearing the background, we can call our empty function. So we call this function depending on the game state, and all the drawing will happen inside. And that would be it for our main function. So we initialize some default state that will be then modified in the menu. And yeah, we set and center the window. It makes sense for us to start with the menu function. And here we'll be actually using the RayGUI package that I mentioned. So let's also import it here. And it has some really simple functions like buttons that are also easy to use and kind of determine if the button was clicked or not. So there will be GUI dot button, right? That, let's see, we pass the rectangle, kind of the bounds of this button, then the text what to show. And as you can see, it returns this boolean, which is really handy to use because we can do something like in a single one-liner, if clicked, GUI.button clicked. So we'll pass the rectangle, right? And then the text would be beginner. What we'll do as dot. So that would be the default, right? So we're kind of switching back to the default, and they should be probably in the constants, but that's fine for now. And then mines equal 10, right? And what we only need to do, we need to draw the rectangle, and the rectangle itself we can draw with Raylib. So in the rectangle we have some offsets, then I believe the width of the rectangle, so let's do it full width, and maybe the size would be default stepper. Alright, it says that we are using unkeyed fields, and yeah, that's my bad. We can actually use the constructor instead of the struct and do something like that, I believe. Cool, much better now. And we can repeat the same. So we'll have 3 difficulties for simplicity. So beginner, let's say intermediate, and expert. Cool, so let's repeat that. And also let's have another button for starting the game. So that would be 16 rows and columns, 40 mines, and then for expert that would be, let's say, 30, and then 99 mines. When we start the game, so obviously we don't need to do that, but we also need to kind of enter the field mode. Okay, so for start, I will define a separate function because in the start, a lot of things will actually happen. So we'll generate the field using the random generator. We'll kind of plant these mines, and then we'll enter the field mode. But let me actually fix a few things here. You see, if we draw the buttons as is, they will all have the y offset as 0, so they will overlap. So we'll need some sort of kind of a counter, right? Maybe let's do base y. So maybe the height will be 50, and then maybe we will do spacing with the same value, and then we'll be incrementing base y with spacing. Cool. And then we'll do the same kind of here and here. And obviously instead of 0 we'll do base y. Let's quickly verify that our menu works. We don't have start, so I'll do that for now. Awesome, so we can see these buttons on the screen. Actually, I wanted start game to be at the end, so I'll quickly fix that, but otherwise it should be functioning. So all the changes happens behind the scenes. We don't print them, kind of rows and calls, but we will see them when we will draw the field. So cool, let's exit this mode. Now come back to our start function. So I'll define it here. I'll speed it up a little bit and just explain how it works, right? It's actually quite simple. So in the start, we need to build the grid because we collected from the user already the amount of rows and columns. So we build this field as a matrix and the point for now is empty, right? Now we randomly plant the mines. So we have the amount of mines we need to plant and then pick randomly the X and Y position on this field. And just in case it already has the mine, we skip it and try again, try to find another random thing because we can't put two mines on the same tile, right? And then we set this pointer to his mine. And then probably the most interesting part of this algorithm that because when we plant the mine, we need to mark all the neighbors and increment the amount of kind of adjacent mines they have. And for that, we can have this recursive function do for neighbors. So this do for neighbors, we pass X and Y, and then also the function which we need to do. And then we can have a small utility function to check if the game is won by checking if the amount of open tiles is equal amount of all the tiles minus the amount of mines, right? So if you have opened all the tiles except the mines, because if you open the mine, the game is lost, and we will do it later as well. Cool. And now let's continue to the draw field. And here I actually want to print some status bar in the bottom of the screen. So I believe we can do, the GUI also has GUI status bar, where again we will pass the new rectangle here as a function and then some text. And for the text I'll do maybe get status function. So in the get status we can print the current FPS as well as time elapsed. So let's get first the FPS from Raylib. So Raylib would be get FPS exactly. Then we can calculate the elapsed time. So let's define it, though it will be different depending if game no, it's not game, right? It's state. So it's won or over. Then we'll use the finish at. Right, so over elapsed will be equal, was that as finished at, right? And we subtract as started at. Otherwise, if the game is still going, we can just use the start at. So elapsed will be time, I believe it's since, right, since as started at. And now we format all of these as a string, so return printf, then do something like FPS, I believe it's an integer, and then time, we can do float in seconds, probably FPS, elapsed dot seconds, but it's not highlighting because, yeah, I believe all of that returns time duration. And when we go back to our draw field, we need rectangle. So the offset of X would be 0, but the height, we need to get the height minus size, I believe, and here, and then cool, let it be full size, so we can use the width here, and then our default size step, which is 30 pixels, and then we print the status. And in the status bar, let's also place the restart button, so we can, restart the game easily. So we can do, so obviously we need to set, again, the rectangle here. So again, rectangle, new rectangle, something like that to put it on the bottom on the right, and the title would be restart. Cool, so let's see if that still works. Awesome, first of all, we fixed that, right? So start one, and let's kind of start with the beginner. Start one, so the screen is quite small. We print the FPS. So our target was 60, right? So it prints around that, and the time in seconds elapsed. And then when we click restart, let's pick intermediate, I believe. So we don't print the field yet, but the size should be bigger, right? That's all correct. And all stays as is. So expert, and the screen is quite big, right? It doesn't fit my screen even. And so here I've added the main logic for drawing the field. It's actually not that hard, but we iterate over the rows and then columns. And then the first kind of check would be if the game is over, and then we reveal the whole game. So we print the bombs as the star with the red color. So we are not using images here, though in Raylib you could load the textures, but we simply print as text. Otherwise, we print the amount of mines around, and for that I created this function getTextColor, right, that basically defines the color based on the mines count. And so yeah, that was for the game over. Then we defined some rectangle for our button and do some small processing if the right button of our mouse was pressed, and then we mark this tile, right? And then here's the main kind of block to draw this tile. If it's marked, we print the capital M with the violet color. If it's open, we show the mines around, and then otherwise it's a button. It's a button without any text, and you can either open it by clicking open, and then we call the reveal tile, or you mark it with the right press. Awesome, so we almost have everything that we need for that game. The draw congrats function is still empty, so let's also do some very simple thing here as just simply draw a text as well done and maybe a button in the middle to play again. So I'm super excited now to try it out and play, and probably till the end, so let's see if it works. Awesome, so we still see our menu. Let's obviously start with the beginner. Alright, so we print, that's our field, that's our buttons in the middle. You see, it's very responsive. Obviously the game is really simple anyway. How you play Minesweeper, right? You kind of randomly pick and try your luck, right? So I'm doing this, it has one around. Very hard to start, or much easier, right? So you start with the corners, and then it has two, obviously here, this already has. And the last one, well done, cool, the game is won. And yeah, we can click this play again button, we can pick the intermediate, and then you try, this is a game over. In probably 1 hour of this recreational programming, we've been able to create a very simple Minesweeper game with Raylib in Go. Yes, some visuals been missing, but actually the gameplay felt exactly as it felt in early 2000s. And Raylib kept its promise and was exactly fun and easy to work with. I will definitely try something else, probably using Zig this time to avoid CGO and compile it to WebAssembly. That's it for today. Thanks for watching. Hit the subscribe button. Bye, nerds.